All right, hi again. So in this video, we're going to look at stretches and compressions, and we're going to start off with y equals f of x here. So this is our original relation, y equals f of x, and we're going to do some transformations on it, which are going to be stretches or compressions. Now, just a little note about stretches versus compressions. Now, if you stretch something, you're making it longer, and if you compress something, you're making it shorter, okay? So they're inverse operations of each other. Okay, so now, if we look at this first example, we've got y equals 2 f of x. Now, notice this 2 is placed on the outside of my f of x. Okay, my f of x is here. It's applying to the entire f of x. So all of the y values are going to be multiplied by 2. And if we're looking at y values on a table of values, your y's are going to be multiplied by 2. So everything is going to be stretched and it's going to become twice as long, I suppose you can say. Okay, so let's jump to this example and look at the y values and see how they change. So right here, my value for y is 2, and now if we multiply that by 2, we end up getting 4. Over here, same thing, all right? That's a horizontal line, so there's not really much change. We're going to look at this key point right here as well. So here we have y equals 1. 1 times 2 equals 2. And here, y equals 0. So 0 times 2 is 0. So it stays the same. That's an invariant point. That doesn't change. Right here, we've got y equals 1. 1 times 2 is 2. All right, so those are all of our points that have been stretched. And now I can grab my straight edge and I can connect the dots. Okay, so this is now our newly drawn y equals 2 of f of x. All right, and if we look at mapping notation here, our mapping for this is going to be, there's no changes applied to my x, there's only changes applied to the values of y, and they're multiplied by 2. So that's what the mapping notation looks like. All right, let's have a look at the other example here. So we've got y equals 1/2 f of x. So for this, we're going to multiply all the y values by 1/2. It's a vertical stretch factor of 1/2. Now, you could look at that as everything, like if it was this, it's going to be half the size now. And there's another way of saying that. You could say that's a vertical compression by a scale factor of 2. And you could also, if you're doing the operation, you could think, okay, I'm going to divide every y value by 2. So either multiply by 1/2 or divide by 2. So let's take these points here that we started off with before, and now we're going to divide everything by 2. So this point was 2, now it becomes 1. This was y equals 2, now it's y equals 1. This is y equals 1, now it becomes y equals 1/2. This is 0, there's no change for that one. And for y equals 1, that now becomes 1/2. All right, so same thing, take your and redraw the graph. Okay, so this is now y equals 1/2 f of x. And the mapping notation for this is simply x, y, it becomes our transformation, we get to there, and it's our x's, there's no change because there's no change applied to the x's, right? Remember that over here? It's just on the y, on the whole f of x. So we're multiplying everything by 1/2, all the y values by 1/2. All right. Now, to the other examples on the next page, this is what we're going to start off with. And what we're going to do is we're going to sketch the following graphs. The graphs are y equals f of 2x. Notice the placement of this now. The 2 is inside of the bracket. It's being applied on the x. And over here, I've got f of x over 2. So our x values are affected. In this one, we're going to multiply our x values by a half. And this is kind of something that you need to remember that's a little bit special. And over here, even though we have a 1/2 on the inside, we're going to multiply everything by 2, all of our x values by 2, to see how the change comes out. So this is a little different, and we need to kind of make a little extra note here. Like with translations, when we did, remember when it was moving left or right, our movement was opposite to the connecting sign. It's kind of the same idea here. When the value is associated with x, the opposite operation is performed from what is presented. So over here you see 2 times x, but in reality what we're going to do is multiply the x values by a half. And over here we've got x divided by 2, so we're going to do the opposite operation. We're going to multiply the x values by 2. Now, I like thinking of it this way. The y values are going to stay the same. There's no change on the y values, but the x values are changed somehow. And in order for our y values to stay exactly the same, how does our x value need to change in order to compensate? Okay, so if you set up a table of values and have a look at that, you'll notice that. Okay, so for the first example, we're going to do y equals f of 2x over here. We're going to take all the x values and we're going to multiply that by a half. So everything is going to be squished. So here we have x equals -2. That becomes x equals -1. Here we've got x equals 0. That stays the same. That's an invariant point. Our x equals 1 now becomes x equals a half. Our x equals 2 now becomes x equals 1. And very quickly we get our compressed graph. So this is y equals f of 2x. All right. And now let's go on to the next one. This one was f of x over 2. So we're going to take all the x values and then we're going to multiply them by 2. So our -2 becomes -4. Our 0 stays the same. Our 1 multiplies to a 2, and our 2 becomes a 4. So now this is our new graph. So we've got y equals f of 1/2 x. Okay. So make sure that you're practicing these questions. I'm going to end this video for this one, and in the next video I am going to do a bunch of examples, okay? So see you soon.